environmental accounting, including the ecological taxes. Ladies and gentlemen, Professor Bandyopadhyay has over 70 research contributions and published many papers in the reputed national and international journals and won many awards for those. He was second Vice Chancellor of the Guru Gobind Singh Indraprasth University from 2008 to 2013. Ladies and gentlemen, there is a lot to his credentials. Presently, as a mentor to Amity Institute of Environmental Sciences, he is constantly guiding us and helping us to achieve the best of our potentials. So may I now humbly request sir to say a few words to the gathering.
So, Amina, thank you very much. Thank you indeed.
Pleasure.
Now, I will start with a proverb. The proverb says that well begun is half done. So we began this deliberation of this very important 10 income workshop on the first day with the presence of the none other than Secretary Arts Sciences, Dr. A.M. Ravichandranji, the Director General, Dr. Mrityunjay Mohapatra, and very senior scientist, Dr. Patnaik. So they made the ball to roll, and with their beautiful deliberations, we were enthralled to listen to them and their insight of the subject. Now, today, again, I've said a proverb, all good that ends good. How better it can be the good when the two very eminent persons are sitting before us, who is the doyen of remote sensing. One is Dr. Prithvi Nag and another is Dr. Prakash Chauhan. All have got very eminent personalities and has got very eminence in the field of remote sensing and its applications. And I visited the Remote Sensing and Application Center in Dehradun when I was the Vice Chancellor of IMS Unison University, where I stayed for 3 years, and I had happened to visit them a couple of times. And it is such a beautiful facility they have created over there. Now, having said so, I like to just say a few words. Now, why we took up this workshop containing program? We wanted to give the emphasis that when all over the world the climate change is becoming everywhere, whether it's a coffee table, dining table, lunch table, everywhere the discussion is taking place, that what is the immense impact it is going to create for the survival of the mankind. And now, under these circumstances, everybody, starting from the political leaders, world political leaders, national political leaders, including our honorable founder president, everybody is worried about how best we can control the temperature rise. How do we control the global warming resulting to climate changes? Now, we know that as a scientist, when we talk about modeling, it has got two different perspectives. One is that either we go by statistical modeling or we go by mathematical modeling. But typically, when you talk about the climate modeling, the most acceptable norm is that going to be that use of mathematical equation to characterize how energy and matter interact in different parts of the ocean, atmosphere, land, so that interfacing and interactions, if we can parameterize it, if we can access, can find out those values, then it can serve us two purposes. One is cause-effect relationship or causal effect relationship, to understand the system, how the system is formed, how the system grows, and if we understand that, possibly that understanding will lead us to develop different types of forecasting models. And if we can forecast floods, if we can forecast tornadoes, if we can forecast nor'easters and nor'easter disturbances, if we can forecast why the global warming is taking place, what are the causal reasons that is coming up, how much erosion is going to contribute over there, how much other types of pollutions are going to contribute over there. And if we can parameterize them, if we can access them and fit into our model, and then we can use the model in terms of either understanding them or in terms of using them. Now, whatever we do it, we need data. Now, where from the data comes? Either we collect the data from our manual interventions or by our different type of data collection. So like, rain data, temperature data, pressure data, or at a different layer, surface to up to say 1.5 kilometer, 2 kilometer data by sending the balloon on the sky. We can collect those hydrological data. But most important thing is that interactions data, where from you get it. So remote sensing application is remote sensing itself is a different field of study, but whatever data that we get it out of our remote sensing agencies or remote sensing department, those interpretation of the data itself is a different field of study. But having interpreted them, taking them their values and inputting them into our model gives a different types of challenges before us. Now this 3 days deliberation, essentially we wanted to highlight the different facets, because I was listening to different different speakers, and the Dr. Patnaik, the way he started the climate change and challenge of extreme weather predictions, and it was very fascinating. I listened to that. I listened to another lecture by Sri Arul Kumar Kannan, Weather Radar Aid for Heavy Rainfall Vulnerability Response. The third paper, the third deliberation I heard is Dr. Usha Meena, Climate Change and Food Security. And if the change, climate change takes place, and what is going to be the impact of the food security and under the Sustainable Development Goals. And then Suraj Kumar Singh, geospatial technology for hydrological modeling. Then, I also listened the lecture of Dr. Archana Sarkar, the modeling of climate change impact on water resources with special emphasis on Indian river system, because our river system now, is under different types of pressures, all sorts of pressure, water pollution, then the utilization of through the dam and making the river flow totally change, and so on and so forth. Then Dr. Sulangana Misra, WMO's role in hydrological and water quality modeling for improving the climate change resilience. Very interesting lecture. I heard it, and I actually added a lot of value to me. And I believed in a similar way that Sheikh Adil Adrisi, exploring marginal and degraded lands through geospatial technology for forestry and biodiversity plantations. Then I also liked Dr. A.K. Mitra's monitoring weather and climate using remote sensing and geospatial techniques. And our own Maya Kumari, climate change induced dot vulnerability assessment using geospatial technology. So, I mean, you can see the gamut of discussion that take place, covering every aspects, more or less every aspect of the societal requirement or societal needs. Now, I believe those who attended, as a student, as a researcher, as a faculty members, there will be plenty of things that they will be able to take home over there, starting with understanding, and then further probing into how really these models get developed to. What are the different assumptions under which we do it? Because many times this statistical model does not give us much more benefit, but again, mathematical model also, if we want to simplify the nonlinear equations, that gives rise to different types of changes over there. So that's the reason we say that model building is a very, very most difficult and challenging work for a scientist. And with a very humoristic tone, I like to say that these assumptions are really made us not to actually understanding the reality. So some authors wrote somewhere that if we are searching the horse, we may get the donkey. There will be four legs. There could be one tail. There could be one nose, two eyes, and one face with two ears. But again, the size may be different. size may be totally, not properly, evaluated. So, but our continuous effort is this. Continuous effort is this, that how do we really come to the ground reality? So whether it's a short range forecasting, whether it is mid range forecasting, whether it is long range forecasting, and so all those assumptions, how can we rationalize it? How can we develop a better type of model? Because still most of the models, if we just see forecasting model, all we are using Navier-Stokes equations, Kelvin's equations, then thermodynamics, second law of thermodynamics in terms of understanding the interfaces between the between the energy system and our atmospheric system, and the way the clouds get formed, whether these cumuloconvective clouds, whether it is cumulonimbus clouds. Still, we do not know cumulonimbus cloud. How do we measure the height of the cumulonimbus? How do we predict the height of the cumulonimbus cloud? How much electricity is inside the cumulonimbus cloud? Whether any cumulus cloud, how much water is droplets are there, so that water the cloud seeding can take place and water precipitation can be made in the dot area. So all those challenging problems are before us, and this training program will essentially sensitize all our scientists, all our students, all our researchers, and actually, I have learned a lot about this, and all credit goes to faculty members of MIT Institute of Environmental Studies. And this MIT Institute of Environmental Studies is the brainchild, none other than one man, that is Dr. Ashok Chauhan, who actually, felt long back that the environment is going to be the topmost subject to be discussed, to be deliberated, to be worked out for the benefit of the mankind. And he created that institutions, and and all the time the man all the time thinks about research, dreams about research. Eats while eating, he also thinks about research. So research is now in his blood, and all the time he tells us that you encourage, you inspire the scientists and try to see the challenging problem, how they can be resolved, how they can be solved. And the challenges are plenty. Challenges are before us. So we have to deliberate it, because university is meant for that. University is meant for bringing different people from the different walk of life, and they discuss it, and there is a new idea gets generated, and that new ideas get further explored too. Now, this is also one of our ventures, and I must congratulate Dr. Renu Dhupar and Manjura Rawat, Amrina Sardar, Richa, and for taking the trouble, because I understand continuously for the last 1 week, you are all working till late evening at 8:30, 9 o'clock in the night in terms of, arranging and formulating this training program. And it's lots of, behind the scene, other people are also involved behind the scene. They have worked it, and really, it's highly praiseworthy. And I'll be failing in my duties if I do not, recognize the contribution made by IMS, IMS Society, and they gave us the responsibility for conducting this workshop. It has been sponsored by them, this training program. So we have already mentioned that we have made our journey together, and we shall be walking a long mile, because this is a very, very challenging field. Modeling is itself a very, very challenging field. Remote sensing is a very, very challenging field. And Dr. Chauhan has also created MIT Institute of EIGRS, we call it Geographical Remote Sensing Institute. There also we are doing lots of researches, including the drone researches for the data collections, data interpretation, data analysis, and actually model building. Now, with these few words, we look forward for such type of challenging training seminars. And also maybe in the next few months, we'll be planning for a conference in this area, because this is where the challenge is lying. So thank you very much. I must also thank Dr. Tonu Jindal. He was the person who initiated the department and created the department, what is today. And we have got every field of environmental aspects are being studied over there. And we have got about 45 research scholars today. They are working on different facets of environmental studies, including remote sensing and its applications. So with these words, I once again thank you all. Thanks, Abrina. Thanks, Renu. Thanks, Manju. And also, I must add, Richa, I must also thank our today's guest once again on behalf of on my personal behalf, on behalf of the total Amity Universe, on behalf of our founder president, and also on behalf of our chancellor, because our chancellor all the time says, together we shall change the world. And we are going to be together. And every sphere, we are trying to connect with each other. We are trying to bring a synergy. So let us work together wherever we are, because we are to work for the benefit of the mankind. So thank you very much.
Thank you
so much, sir.
Thank you, sir. Thank you, sir.
Thank you so much for your wonderful and insightful words, sir. And it's always a privilege learning from you and working with your guidance. Thank you so much. Ladies and gentlemen, I'm feeling so privileged and honored to invite our guest of honor for today's evening, Dr. Prithvish Nag, ex-Vice Chancellor, Mahatma Gandhi Kashi Vidyapeeth Varanasi, DDU Gorakhpur University, Gorakhpur, Sampurnanand Sanskrit Vishwavidyalaya Varanasi, Uttar Pradesh Rashtriya Tandon Open University, Allahabad, former Surveyor General of India. Ladies and gentlemen, Sir is a gold medalist from Banaras Hindu University. Sir did his PhD in Zambia and Fellow of the Royal Geography Society, London. He did his postdoctoral research in South Central Africa School of Oriental and African Studies, University of London. He's a recipient of Commonwealth Bursary by Royal Geographical Society. He authored and edited over 135 papers and 77 books. He served as scientist engineer in the Indian Space Research Organization, ISRO, former director, National Atlas and Thematic Mapping Organization, Department of Science and Technology, Government of India, former chairman, GIS Executive Advisory Committee, Kolkata Municipal Corporation, former chairman, Permanent Committee on Geographical Infrastructure for the Asia and the Pacific, International Committee on Institutional Strengthening, former chairman, International Steering Committee on Global Mapping Committee on Data Standards, former chairman of the Commission on Population Mapping of the International Cartographic Association, former member for 2 terms of the Commission on Population Geography of the International Geographical Union, chairman, expert committee, National Geospatial Program, Natural Resource Data Management System of DST, Government of India, chairman, expert committee, National Spatial Data Infrastructure of DST, Government of India, president's nominee to BHU and Allahabad University Courts, executive council member of Manipur and Mizoram Universities. Ladies and gentlemen, there is a lot to his credential. Currently is engaged as visiting professor with a reputed institution in our country, transferring his immense knowledge to the younger generation of our country. So with all humility, I now request Sir to please say a few words to our gathering. Over to you, sir.
Thank you very much, Dr. Amrina, for introducing me. Needless to say that I'm delighted to be for the first time with any activity of the Amity University. I've been hearing about it for a long time, but today I was able to connect with you all. Thanks to the Honorable Vice Chancellor of your university, Professor Balvinder Shukla, Madam, Professor D.K. Bandyopadhyay, Dr. Manju Ranjan, Dr. Renu Dhupar, Dr. Nagar, Dr. Amrina, of course, the chief guest of this occasion, Dr. Rakesh Chauhan, Dr. D.R. Patnaik, and participants. Today, what I will be talking about is a different issue. It is not exactly the climate modeling or remote sensing application, but how we can get the positive side of climate change. What we can consider as an option also. You must have heard very gloomy picture of climate change, and things are getting in a different ways, doomsday description type of thing. but I will try to explain some brighter side of it, that how we can make advantage of it. What are the potentials? Can we get business out of it? How the industry, the financial institutions, they are looking at the climate change. So can I have my presentation here? Can I have my presentation on the screen, please? Yeah. So the topic which I've kept is the potential business out of climate change. How to move it? Can anybody explain? How to come to the next slide? Yeah. So when I was a student, I used to have a book which was named as The Unstable Earth by J.S. Steers. It was published in 1932. Those who are students of geography and geology, they must have heard about this book. The message which we get from this book is that things are always changing. There is nothing which is all the time same. Hence, the change is a constant thing. So very slowly it's moving. Yeah. So there are some presumptions which have been, which was Dr. Bandyopadhyay was mentioning about it, that we have made some presumptions. Earth continues to be warm in recent years. Warming is mostly due to the human activities. Greenhouse gas emission will not cease. Rising temperatures have already made impact in altering the Earth's climate. Consequently, change in hydrology, water resources, agriculture, food security, freshwater ecosystem, coastal zones, etc., including human health. So these were the assumptions made, and largely these assumptions still continue. I've been noticing this since last 2 decades, that people keep on talking in those terms. Yeah. I don't have to describe this. Professor Bandyopadhyay already mentioned that this whole land, ocean, etc. This all is a one system, one climatic system is connecting everybody, and one change in one thing may affect change in the other side. Yeah. So the trend which is considered is that average temperature the planet is increased by 0.8 degrees Celsius. And there are several records which are available, which also indicates towards that since 1850. The pace of current CO2 emission, scientists expect on increase between 1.5 degree to 5.3 degree. These are all the assumptions we made, and obviously this will be having negative impact on the humanity and the biosphere. I tried to get some data in this regard and found that over the years, the temperature is around 1 degree is likely to be changed as per the estimation. But I understand that a lot of people from meteorology are there. They will be able to explain that what exactly, how much change, how much degree temperature has changed, and in what latitude it has changed along the coast, along the equator, and elsewhere. Yeah. Further, the greenhouse effect is a natural phenomenon. However, the increase in greenhouse gases is likely to be linked with the human activities, which has been discussed, and I presume from the descriptions given here that a lot of discussion has been made on this. The solar impulse label is granted to be an innovative solution to global warming that meets the high standards of sustainability and profitability. Each solution goes through a strict assessment process, and efficient solution are also, we are trying to make it out. Now, despite of all these things, new knowledge and skills are being introduced. Companies are being asked to have their assessment about the change. 1,500 companies were asked to disclose that what they think about the forest-based commodities. Around 350 companies, they responded, but others, they failed to respond in the last 3 years. But deforestation, as you know, has affected in a different way. The major brands, I'm talking in terms of the companies which are working on this, the major brands, including Mondelez, Sports Direct, etc., use commodities that are directly from the forest products. Meanwhile, these companies that did disclose in 2018, nearly a third did not disclose the forest-related issues and their risk assessment as well. Some 92% of the companies that do assess such risk, seeing the substantial impact, it is clear that the business and financial risks associated with the forest are going to be underreported and ignored. So what I'm trying to suggest here, or give an indication, that there's an underreporting also in this regard, that what exactly, how exactly, which Professor Bandyopadhyay was mentioning in a way, which is not 100% reported. It can be interpreted in one way or another. But this is one sector of deforestation has been taken here. So you can connect that how this thing, climate change and underreporting or no reporting or less reporting of the actual ground reality. 3 positions about global warming are very well known. That global warming is not occurring. This is 3 models which are being considered, which are being discussed. That global warming is not occurring, so neither there is global change, the climate change. So this is one opinion. Second opinion is that global warming and climate change are occurring, but these are natural cyclic events unrelated to human activity. This is the second model. And third model, which we keep on discussing, that global warming is occurring as a result of primarily human activity, and so the climate change is also a result of human activity. So these 3 models are in front of us, and we keep on discussing all these 3 models, that whether it is affecting, how it is affecting, whether it is a cyclic or a natural phenomena, etc., etc. Yeah. The disputes are as follows. The climate scientist and the environmentalist either dispute or suggest that the timing issue, that is the rapidity with which the globe has warmed and the climate change study, do not fit the model of the previous natural events. So this is one opinion, that it does not fit in the whatever is claimed or whatever is said or discussed. The data strongly suggests that the solar activity affects the global climate in many important ways, but it is not a factor in a systematic change over time that we call as a global warming. So all the effect of so-called global warming may be in some pockets, maybe in some regions, maybe in some part of the globe, but it is not a universal factor. So it should not be considered that it is affecting the whole globe similarly in the same way. Again, the projections are like this, that the natural greenhouse effect, how it will affect the globe, and how human enhanced greenhouse effect will affect. So these are the few models which are being brought out, affect the CO2, NO2, etc., etc. Again, the greenhouse gas trapped energy includes a lot of things, which Professor Bandyopadhyay has discussed here. So they're all related to each other. One will affect the other, which may create droughts, which may create more rains, less rains, larger spells, smaller spells, within a small spell, a lot of rains. Now, if these things, these changes are to be considered, I come to the main topic, whether this will affect and how it will affect the economics and the business. This is an area of research, area of further studies. These type of topics are generally not studied in the universities, institutions, or academia, but it is more studied in the banks, the financial institutions, the international bodies, etc. Because they want to know where to invest. And they find that climate change is a new area where the global economy is likely to change. Hence, there is a scope of more investment. So which are the sectors for investment that is to be looked at? The economic cost of climate change is also significant, 0 to 0.3% of global GDP annually, till Earth temperature rises to 2 to 3 degrees centigrade. So there is an attempt to link the change in GDP with the temperature. And this is done by all these financial institutions, basically. However, it will pave way to new economies and fresh impetus to business houses. See, if you consider the whole world and the economic situation of the whole world, you will find that it has become saturated. The areas which are known for industry, the saturation is there. Known for agriculture, regions are saturated for agriculture, or for tea growing areas, or for plantation, etc. Now, this climate change is little bit shaking the world, and some scope is perhaps we can get that, yes, some more scope for investment activities, research, studies. These things are coming up. Now, should we ignore all these things, or should we take it as an opportunity? This is the issue. Greenhouse gas concentration, increase in temperature, and their impact in economy and ecology are related. So these relationships have to be considered. Now, what are the features which you are getting? The geographic features, the shrinking of glaciers, thawing of permafrost areas, delay in freezing and early breakup of ice in rivers. These are the topics which we keep on discussing, that what is happening. We keep on discussing at a global level, but it may not be at global level. It may be at local level or in certain areas. If there is glaciers are shrinking somewhere, glaciers are increasing also in somewhere. Early flowering of trees, decline in some plants and animal population. So these are the few features which we keep on discussing. Now see our situation. Earlier, you see the left-hand picture. This was like this. Then there was change. And after that, you see the right side, that the area which we get and we use for housing, population, plantation, agriculture. So we are getting also something out of climate change. If it is desirable, we use it for the economic development. If it is not, we have the technology to control it. So there has to be balance, that the benefit which we get, how we appreciate, how we take advantage of that. As a result, areas liable to change are coastal zones, marine systems, higher altitude areas. These are likely to change, slightly fragile areas. Water source, agriculture, crop yield, forestry, etc., likely to change. The other geographical features like risk of drought, change in sea levels, degradation of water quality, regarding health, frequency of some diseases, additional deaths, etc. These are the issues which are people do connect with the climate change. Regarding the say coastal area, for example, if the water level is increasing, coastal water level is increasing, which means you require more areas for new settlements. And as you know, coastal areas are well-populated areas, which means more investment in interior areas for resettlement or depopulation of that area. Similarly, if you are getting increasing some areas, you are getting some areas where it was earlier something else, and now due to change, this is the land use has changed. If that land use is useful for you, use it for the economic benefit. Displacement of population will be another area of investment. The usual changes you can see in the picture here. The coastline has shifted or likely to shift, and this will affect the coastal area where population can shift inside. The projection suggests a climate change impact within 100 years, if not sooner. The world glacier will disappear, as we see in polar cap areas, including Antarctic and Greenland, etc. Snow will have become a more rare phenomena at what are known to be world most popular skiing areas. This may also change. So these are the likely changes which are being mentioned, which are being projected, that is how the things are likely to change. But these are all very localized. It is at the local areas, it will have some issues. But due to this, the factors likely to change the business models. Globalization is one. The policies and regulations will change. There will be demographic changes. In fact, from 2050, the population will start decreasing worldwide. That will have a different impact, but I'm not going in details into that. But demographic changes will be there. Depopulation and redistribution of population will be there. Changing pattern of demand. Earlier, say if the temperature increases by 1 degree, there will be change of demand. More clothes will be different. Food habits will change, which means more investment, more research in these new areas. Production methods will change. Geographical location will change. So all this change will follow the climate change, and we should be appreciated. We have identified different types of risk climate change poses to business, which are prices, rating, reputation, etc. All these things are integrated in terms of companies who are running business, who are producing certain things. I will give you one very small story. In NATMO, we prepared a map of natural hazard, which shows that different type of natural hazard and multiple hazard areas of the country. Within 6 months, the maps are sold. We used to print 2,000 maps in one shot. Then there was demand there again to reprint this map. We reprinted it again, that was sold. And I was wondering that other maps are not sold and why these maps are sold. So I called the fellow from the map sales section and asked him that why these maps are so popular. He could not reply because the salesman. Then I told him that whenever next person comes, please send it to me. So that fellow came to buy a map. I asked him why you are going to buy this map. What he said that with the help of this map, his company will try to understand which are the more risk areas and what type of risk is there. And based on that, the insurance company will make the insurance policy. So what I'm trying to say that with all these problems, there is an economy part also linked with it. The implications will be slow moving changes, but effective. All this climate change are slow moving areas.
Response until there's a crisis. Okay? And of course, there's an ethical issue. All the things we have done in the last 100 years for rapid economic development is going to affect the future generations. And so we
Dr.
need
Puneet,
now
sorry,
that into account, not just
I don't know.
Puneet, sir,
to people living in Earth today,
Puneet, sir,
but
please listen to
just to
the
people
matter.
Okay. So slow moving changes, there will be slow moving changes, but effective. Changes in asset values. Say some property which is exposed to certain risk, that will be the property, the value will go down. Falling equity market values and bonds, mismatching between the insurance and the pension funds, government bonds will be favored, and increase in fund deficit. These are the financial implications of that. Yeah. This will lead to what? This is an interesting part. New technologies and new business equations linked with the climate change. Major sectors may be automobile, utilities, integrated gas and oil, chemicals, etc. So the new expertise and specialization will be an integrated thing with policies, mega industry at firm level. So all these things get related with the climate change. So that is the interesting part. Yeah. At firm, sorry. So slowly responding. Just jumped several slides. Okay, whatever it is. There was a Clinton climate initiatives, which says that business orientation approach to global warming, cities with energy efficient upgrades, 40% of the global greenhouse emission that will be there, funding, loans, etc. required from banks for heating, cooling, lighting to reduce the energy cost, and building retrofits. These are the areas which have been identified with the climate change and where the possible funding is required or finance is required. So CCI means Clinton Climate Initiative will save money, make money, and more jobs. Further, more environmentally friendly initiatives are required. Earlier, we never used to bother these things, but now the new researches, new studies, new investments will be in these sectors. Small groups can make an impact. See, bigger industries, they are difficult to change, but the smaller industrial units, they are swift in changing. So along with the climate change, they can change faster. So that will be advantage in the climate change scenario, what the industry will be looking at it, or industry will affect it, how it will affect it. In my own area of mapping, if there is climate change and sea level increases or decreases, this will change the mean sea level, which means whole datum will change, which means whole mapping will change of the country or any region. Then we require more investment in terms of the foundation data mapping, based on which GIS, GPS, all sort of activities are governed. So a new sector of investment comes up. Digital elevation model will change because the sea level has changed. Military strategies will also again change. New investments are required. Impact on topography will vary regionally. Hence, there is a new business potential which are likely to be changed if the sea level changes. But from my background of Survey of India, we have been recording the coastline for 200 years or so. But there's hardly any change. Changes are locally. The conclusion of the CCI or Clinton's initiative that climate change will make slow but definite changes. There will be new business opportunities, production, consumption, and expenditure pattern will change due to this, which means new type of products are required. Companies which can tune their production and business with climate change will be gainer, which means that there has to be within the companies, there has to be a research group, a study group, which takes care of the climate change and how it affects the business. Those companies will survive. In-house study groups or consultancy related to climate change will be an important component. So these are the new sectors of study and research, which we have not been considering very seriously till now. But as I mentioned, the banks and the financial institutions, they do. The best reports are available from them only. The Forbes found findings are as follows. Forbes, you know very well. Business leader must understand how their general business decisions, choices made about marketing, production, and finance should change due to the warming climate. Some of the most ardent climate advocates previously argued that we would face worsening pollution, resource scarcity, massive famines, and other disasters. None of these has happened, and they are now saying that the climate change is threatening our lives, and it seems that we have watermelon activist, green outside and red inside. This is the Forbes report which says. Further, the corporate planning with climate change should be based on two major points. First, that the temperature change will continue, though not all at the pace suggested by the extreme worries. Second is that uncertainty about future path is great enough that warming could be much worse than the predicted or could be even reverse itself. Finally, in Bhagavad Gita, what it says, to live is to live out. New form of life are built at the cost of old ones. Destruction is involved in construction. There's a positive side of it. Unalterable is the scheme of nature. Not a moment passes without destruction taking place. Recognizing this truth in its nakedness is the first step in understanding the plan of future. So things will change. It may lead to destruction, but this is the way how it is. Unfortunately, some slides I have to skip because it was not coming. But my message, what I want to say, that climate change should also be considered as an opportunity which has come. More, you require investment in research, in making new products, new type of technologies, new type of way of thinking. And this is how the new economy will grow, taking advantage of climate change. So that may be considered as an option. I'm not saying that everything is very good regarding climate change, but you can take it as an option and consider that the opportunity which is given, how we can make best use of it. Finally, thank you very much for giving me a chance to explain my understanding of climate change. Change is constant. This is what I want to say. Thank you very much.
Thank you so much, Prithvi sir. And indeed, it was a pleasure listening to you and gaining from your experience. And very rightly said that the destruction leads to something constructive. And with that positive note, again, I'll take this opportunity to thank you on behalf of the entire Amity University, although it is for the first time, but it is for lifelong association with you. And thank you so much. And it was pleasure listening to you. Thank you so much, sir.
Thank you, sir. Thank you. Thank you.
Moving ahead, ladies and gentlemen, now I'm very humbled
Sir
and
Nag,
privileged.
just 1 minute.
Ji, sir, please.
Yes, sir.
Professor Nag,
Yeah.
I was listening to your deliberations
Yeah.
very minutely,
Yeah.
and I was just trying to map it.
Yeah.
What our honorable founder president says.
Yeah.
He says crisis is the genesis of opportunities.
Yeah.
So when the COVID started, he said there will be crisis. And this crisis, how do we convert it to the opportunities?
Right.
And everybody who are there in the business or in the society, they would like to take this as an opportunity. I mean, very well said. And
Yeah.
we also know that, we have got Brahma, Vishnu, Maheshwar.
Yeah.
Is creator, one is creator, one is maintainer, another is destructor. So without destruction, no creation is possible. Very well said, sir.
I hope that you will you will initiate some research in this area.
Yes.
Climate change with economy and business models.
Yeah,
etc.
already said, already there.
Yeah.
Environmental accounting system, we are just really try to work it out. Environmental accounting system. And we actually, with our intervention from Bhopal, we try to, and now we are trying to do over here, that concept of the ecological tax, it came as an opportunity.
Yeah.
So Uttarakhand is telling, why should I maintain so much of my forest? Why? I do not get any revenue out of it, because now forest conservation doesn't allow me to earn any money out of it.
Yeah.
So, but again, they are maintaining the water downstream. They are maintaining that, they are working as a sink, carbon sink. So they, that comes the concept of how do you really account it, and it's a new business model, and how they can be compensated. That's how Planning Commission, now they have introduced the concept of ecological tax, and they give some percentage in their, when a grant sanction in the form of ecological tax. So, I mean, these are new opportunities, new things that are coming over.
The remote sensing part could have been integrated with this, but the scope is not there. I don't have so much time to see that how remote sensing data can monitor the changes, and accordingly the economic change which also follows that. So that part I could not do it because restriction of time, but there is a scope of doing it. That
exactly, sir. Plenty of opportunity. Maybe we'll have further deliberations on it. We'll have some other opportunity depending upon your convenience.
Right.
Nowadays, technology has given us very good opportunity. That is again an opportunity due to this crisis. It has really make us to learn how to reach to the people within no time, quickly, at a convenience, with a very less response time. And these are again the opportunity. And we'll have that type of thing with your convenience. We like to have more interactions with you. Thank you, sir.
I appreciate your chairman's vision as well. Thank you.
Thank you. Thank you, sir. Moving ahead, ladies and gentlemen, I'm very humbled and privileged to invite our chief guest for today's event, Dr. Prakash Chauhan, Director, Indian Institute of Remote Sensing, Dehradun, Uttarakhand, India. Ladies and gentlemen, Dr. Prakash obtained his postgraduate degree in Applied Geophysics from Indian Institute of Technology, Roorkee, and PhD in Physics from Gujarat University, Ahmedabad. Prior to joining Indian Institute of Remote Sensing, Dehradun, he was the group director at the Space Applications Center, Ahmedabad since 2014. He joined Indian Space Research Organization in 1991 as scientist, and since then working for the applications of remote sensing technology for natural resources management for ocean and land resources. He initiated research activities for planetary remote sensing at Space Applications Center to study solar system aims mainly Earth's moon and Mars through Indian planetary mission. His major achievements are in the area of Earth observation application, including development of algorithms for ocean color parameters retrieval, marine living resource assessment, aerosol remote sensing for space-based air quality monitoring, river and reservoir water level estimation using space-borne altimeters, and coastal zone management. He has done lead work in using the hyperspectral data for lunar surface composition mapping using HYSI and Moon Mineralogical Mapper instruments of Chandrayaan-1. He has been the principal investigator for infrared imaging spectrometer instrument on board Chandrayaan-2 mission. He also led a team scientist for scientific analysis of data from Mars orbital mission instruments. He has published more than 100 research papers in both national and international journals. He is executive member of International Ocean Color Coordination Group and representing ISRO. He has also represented ISRO at CEOs as co-chair for Ocean Color Virtual Constellation. Currently, he is a member of prestigious NASA ISRO Planetary Science Working Group. He has been awarded prestigious Professor PR Pisharotti Memorial Award for the year 2004 by Indian Society of Remote Sensing, Hariom Ashram Perit Dr. Vikram Sarabhai Research Award by Physical Research Laboratory Ahmedabad for 2009, ISRO Merit Award by Indian Space Research Organization in 2010, and Satish Dhawan Award by ISRS Dehradun for 2016. We are so privileged to have you with us, gracing this occasion, and I believe the best person to take this 3-day journey to its final destination. Thank you so much, sir. Over to you.
Thank you, Dr. Amrina. Good evening
Good evening, sir.
to all of you, all the eminent persons present. First of all, I would like to thank the organizers of this 3-day workshop on climate modeling and remote sensing applications to environmental system, in particular to Amity University, the Honorable Chancellors, the founding father of Amity University, Dr. Ashok Chauhan, Dr. D.K. Bhattacharya Sahab, who is mentoring all of you, the Vice Chancellor, Madam, Dr. Renu, Dr. Manju, and definitely Dr. Amrina, and all other faculty members, for giving me this opportunity to interact with you all on this occasion when we are, celebrating, or we are just culminating these 3 days, activities of your workshop in this valedictory function. First of all, I would also like, to congratulate Professor Pratish Nag for this wonderful deliberation, and also talking about a very important aspects about the climate mitigation and the business opportunities which are likely to come in the future. And he has very well and nicely articulated the new emerging areas of economic development, which are going to be the consequences of this climate change process. Thank you very much, sir, for this enlightening talk. It was a pleasure to listen to. Similarly, I also heard the views of Professor Bhattacharya in the beginning, where he, elaborated and talked about the climate models, the weather models, the type of models, the requirement of these models for data, because without data, numerical models are not going to work, and how the models have progressed over a period of time, and what likely is going to happen as far as the climate modeling scenarios are concerned. We also heard from the organizers the 3-day, the report on the activities, and I was glad to know that large amount of, speakers you could gather, and very prominent speakers of the country, they participated in your program. That shows the importance of this workshop, and definitely the kind of talks which has been given in this conference will be very useful to all the participants. And I could still see this is the fag end of the day, and almost 100 participants are still there. So it shows that the participants are still hungry for the knowledge. And the basic purpose of organizing seminars and symposiums is to rejuvenate and rekindle, the thought process, especially for the youngsters and young researchers, which basically is driven by the experience of the senior faculty members or the senior professors and senior scientists, those who join these type of workshops. So I congratulate the organizers that probably that the type of conference you have conceived, the type of speakers you brought, it probably has fulfilled the most of the aims which you thought, in the beginning of this conference, and you all deserve a good round of applause for conducting this wonderful workshop on a very important issue, which is, going to impact billions of lives in terms of understanding the climate issues. Now, as has been told, I will not take much time. I would like to emphasize upon, the history of climatic variability on this planet Earth. As many of you are aware, the Earth is a planet which is almost 4 billion years old. It has been continuously changing, in different eras, starting from the evolution from our own star, being a very hot molten body, and then slowly it has cooled down. The atmosphere was basically carbon dioxide rich, and with the adaptation and the the rejuvenation of oceans, and then the primitive life which originated through the planktons, which initiated the photosynthesis process, the gradual reduction of this CO2 led to this, what we see, the current state of atmosphere over these billions of years period. And of course, large amount of phenomena like volcanic eruptions, meteoritic showers, and plate tectonics have also changed the face of the earth during these 4 billion years. And of course, the humans are not that old on this planet, but we have been now of late changing the face of the planet in a very rapid fashion. So if you see the geological records, they show that there have been a number of large variations in the Earth's climate. And these has been caused by many factors, including changes in the solar emission itself from the sun, then large amount of volcanic activities, which has released large amount of greenhouse gases occasionally, and multiple eruptions across the globe has also changed the atmospheric composition, as well as the orbit of the Earth itself has been perturbing over a period of time, which basically is changing the radiation balance on the Earth's surface. However, in the recent history of humans, especially last 100 years history or so, what we call as the post-industrial era, and in particular, I will talk that the climatic variability has risen sharply, especially since 1950 onwards or so, and popularly the CO2 variations in these last 50 years or so are characterized by what we call as the typical hockey stick curve, where sudden large changes in the CO2 concentration in the atmosphere has been reported and recorded. And as we speak today, the CO2 level globally on an average has crossed around 420 ppm, which really is a cause of the worry. Ideally speaking, it should be well below 385 ppm or so to keep the energy balance of the Earth in equilibrium. However, this is all happening because of the human greed and of course the industrialization and the increased consumption due to our population and quest for living so-called good quality life. What really we have done is that we have used the hydrocarbon resources which have been sequestered over billions of years in the bottom of the earth by various geologic processes. We have brought out these hydrocarbon reserves and released this carbon into the atmosphere in last 50 or 60 years, which has dramatically changed the composition or the atmospheric chemistry and created what we call as the radiative imbalance in the atmosphere because of the presence of these large amount of greenhouse gases. A recent study suggests that from 1971 to 2018, the Earth energy imbalance has significantly increased. And today, we have a total heat surplus in our atmosphere, which is of the order of around 350 zetajoules. Zetajoules means 10 to the power 21, and out of this heat, the 1% of the heat has been, absorbed by the atmosphere, 6% has been absorbed by the land, and the oceans have absorbed around 89% of this excess heat, and only 4% has been absorbed by the cryosphere. Remaining, we still have large amount of surplus heat in the atmosphere, which basically having a positive radiative balance of around 0.47 watts per meter square, and which is basically likely to give rise to this so-called 1.5 or 2 degrees Celsius global atmospheric, warming or global temperature rise. So we are paying for our deeds, and these things have been monitored if you talk from the space perspective, because remote sensing is also one of the key things which you have talked in this conference. It is basically due to the large amount of global missions, which started sometime in 80s or so. I can recall a very famous mission by NASA called CSAT mission. It started in 1978. It has first flown what we call as an altimeter instrument. And these altimeters were supposed to measure very precisely the sea level rise. And the precision is of the order of now millimeters or so. So using this last 40, 50 years of altimeter data, the sea level rise trends have been reported by using primarily the satellite-based observations. And today we know around 0.3 millimeter per year is the global sea rise levels. And as Professor Pratish Nag has told, the regional scenarios are varying across the globe. However, globally, the number is also threatening. And if, as you see the papers which are presented in the COP26 conference, if we do not commit or we do not honor the commitments on stopping these greenhouse emissions, the Earth is likely to have, with the current kind of scenario, another 3 degrees centigrade or so by the end of this century. Already we are having 1.1 degrees plus temperature rise since 1850 or so. And we are seeing the consequences on various ecosystems. I need not tell you that. A lot of talks you must have heard during this conference on, on the receding glaciers, glacial lakes, sea level rise, extreme rainfall events, things like, and many other things which are happening, coral bleaching, etc., etc. These are the consequences. So you imagine a world which is likely to have a temperature or the warming scenario more than 2 degrees centigrade, things are going to worse for us. However, as Professor Pratish Nag has told, we need to worry about now climate adaptation because climate change is a reality because of our action. But one more thing which I would like to tell you over here, which you can consider in a long run is the silver line, is that this hydrocarbon dominated economy is not likely to sustain in future. If you see simple statistics, we are only left with good amount of sustainable oil reservoirs for around another 40 or 47 years or so, until less new discoveries are made. So eventually, the humanity has to come out from this hydrocarbon-based economy cycle, and definitely in around another 100 or 150 years or so, which is also a very small time as far as even the human history is concerned, definitely we will be seeing a scenario where probably the amount of greenhouse gases which we are emitting today are likely to get reduced as we live in next centuries or so. However, since our lifespans are also limited, so as this generation and next 2 generations, we need to worry about the climate adaptation, and we need to learn how we can adopt to the changing reality of the earth in terms of climate variability. And as has been told in the previous talks, there will be new scenarios, new business opportunities, as well as the new way of living which is likely to emerge. So I would like to talk about 2 or 3 things where the satellite-based technology or remote sensing technology is going to play a key role in terms of climatic adaptations in times to come. As the business as usual, or maybe a reduced CO2 scenario, if it happens, very good. But the most important absorbers of the atmospheric carbon dioxide are the plants or our forest ecosystem. We need to all talk about, either reforestation or to conserve the current forest resources. In India, particular, we have been doing pretty well, and we, every 2 years using remote sensing data, we are mapping the forest cover, and it has been shown that now we have around 23% of our geographical area under on the green cover. Maybe forest, the typical notified forest, and the trees outside forest region. But the worrying aspect to us is that around 41% of our total forest area is almost under degraded forest system. And we need to take quick action for afforestation or taking region restoration of these degraded forest systems. And there is another good business potential or research potential of remote sensing systems or remote sensing data sets to identify these degraded land parcels within the notified forest or even outside forest systems. Indian Space Research Organization, along with other institutions, has recently brought out a very important document, which is a 1:50,000 scale, desertification atlas of the country, which basically also talk about the land degradation processes as well as the degraded forest related issues. So this is a key area where large amount of action is required, where if we can do restoration of this degraded forest system, the carbon sequestration by by the restored forest for next 20, 30, 40 years is likely to also help us in terms of keeping the balance or keeping our carbon emission scenarios in check. Another second important aspect is, as we move on from this hydrocarbon-based economy to renewables, the solar and the wind potential, wind energy potential. So in this case also, the satellite-based inputs are providing fairly good amount of information. And today, we have been doing a lot of work in terms of identifying the solar potential suitable areas. In fact, recently you must have heard our Honorable Prime Minister in the COP summit at Glasgow declared that ISRO has developed what we call as the solar calculator. It's a very simple app which basically tells you that at a given location, if you are standing, what is the solar energy potential for throughout the year. This is based on the data which has been derived on the solar radiation, or what we call as the total solar radiation, shortwave total solar radiation, which is measured at ground through the help of meteorological satellite systems. So these are very good tools which basically will be helpful to the business people or to the potential solar industry people in terms of identifying the geographical locations for setting up solar power plants. Similarly, large amount of work in terms of understanding the wind regimes and identifying the area where throughout the year, good wind vector or the good wind energy or wind potential is there, especially in the coastal areas and the offshore areas. That type of work is also solely depends on the remote sensing as well as, of course, the ground-based measurement systems. There are some spin-off technologies where ISRO has contributed significantly. And one example I would like to take, you see, we put a very efficient lithium-ion battery in our geostationary communication satellite as well as for meteorological satellites. These satellites have a typical age of around tens of years or so. So these batteries on the satellite systems, not only they're efficient, but they're having long life also. So this technology of lithium-ion battery has been transferred to the electronic or to the electrical vehicle or EV vehicle segment in India by ISRO. And large amount of manufacturers of batteries in India are getting benefited by this technology, which are likely to change our mobility sector in times to come. Another important area which is likely to emerge as we talk about the climate adaptation is the flood control, the insurance premiums, as Professor Nag told, and of course about the water management, because water sector is also going to get affected severely. And if we talk about the water sector in India, you will be surprised that 85% of water consumption in India is by the agriculture sector. So if you have to have a good water management system in India, you need to really bring down this number. And a lot of countries like Israel and other dry and arid countries have shown that the kind of flood irrigation practices we have in India, they are not required. In fact, we are wasting a lot of water, which basically is being pumped from the groundwater resources. So there is a need for smart agriculture as well as what we call as the precision agriculture. And in this, developing these precision agriculture tools and the smart agriculture tools, large amount of remote sensing data in terms of understanding the crop water demand through the thermal remote sensing data sets by estimating the evapotranspiration potential and then other components related to energy balance for the crops are going to be the emerging area where you will see a lot of activities are going to happen in times to come. Improved weather forecasting and disaster risk reduction is also going to be very critical in terms of climatic adaptation. And our meteorological satellites, especially INSAT-3D, INSAT-3DR, which provides information about the emerging weather systems over India. Every 15 minutes, we get this information. And this is assimilated by India Meteorology Department into the weather forecasting models. And you must have seen in last 5-6 years, our ability to predict, the disaster scenarios, especially cyclones and the extreme weather rainfall events have significantly improved thanks to the assimilation of the satellite-based observations into the weather forecast systems. Similarly, the disaster risk reduction has different cycles. the pre-disaster scenario, during the disaster scenario, and the post-disaster scenario. These three components of disaster life management cycle also are going to have more emphasis on remote sensing based systems. Then, all these things, when we talk about, it is also important that we are not still talking about another, dangerous greenhouse gas effect. Mostly people are talking about CO2 and CO2-like emissions, but there is another, dangerous creature which is likely to create problems for us, and it's going to be the methane. Now, methane has almost 80 times more greenhouse gas potential compared to CO2. And as the temperature rise takes place, large amount of permafrost regions in the world are likely to melt, especially in Siberia, in Russia, and in our own backyards in Ladakh and all these regions. And these permafrost regions are basically storehouse of methane gas. So we need to talk and we need to think now about putting up satellite systems in space to make measurements on methane, and also to make industrial methane leaks, because methane is also being used in various industrial aspects, and nothing much is really talked about. Inventories are also not up to date. So that is another important opportunity for remote sensing scientists to think about developing methane detection satellite systems, developing algorithms, and provide good amount of quantitative estimates of methane gas, because the climate feedback system is likely to put methane emissions on a high pedestal in times to come. So we may be cutting CO2 emissions in future, but there is another danger, which is basically going to come out from the natural ecosystems like permafrost regions, etc. So that is another thing which I thought I will highlight. And then, of course, we need to work very stringently in terms of, what we call as the Sustainable Development Goals, which has been put across by United Nations. And space community is doing fairly well in terms of providing almost now 52 number of what we call as essential climatic variables, ECVs, through international consortia effort, where many space agencies are coming together, and through a organization called GCOS, Global Climate Observation System, we are now providing to the community, or the global community, continued observation on decadal scale with good amount of accuracy on this, what we call as the essential climatic variables, which include sea surface temperature, sea level rise, atmospheric chemistry, different gases, as well as state of the snow cover areas, and many other parameters are involved in these type of ECB related aspects. So another important thing which I thought I will close by talking that is about, as Professor Bhattacharya was also talking, is about carbon farming or business of carbon credit. Now, this is a potential area where large amount of contributions from remote sensing scientists can come, and we can connect to the economic activities and with the bankers and people, those who are doing business of carbon credits. It basically works on a policy that the emitter or the polluter has to pay to the sequester. Now, Professor Bhattacharya talked about the classic case of Uttarakhand, where large amount of area, almost 85% of the geographic area is under forest cover. These forests are basically, they are the lungs for the country, and they are basically protected area, and that it also basically hinders, in a sense, the developmental activities. So they need to be paid for, sequestering this carbon, which other states, by doing economic activities as emitters, are paying. So similar concept is also getting developed for agriculture systems. In India is the second largest agriculture dominated emissions sector is concerned, because our agriculture is really huge. And now companies are talking about regenerative agricultural scenarios where the farmers are supposed to be given incentives for doing more regenerative farming by adopting less tillage practices, by putting less amount of fertilizers, and also producing the crop or adopting the crop cycles or the crop rotation patterns, so that the soil nutrients, you require less amount of artificial insemination of nutrients in terms of fertilizers. So to monitor these aspects, a lot of remote sensing technology are going to come up, and that's going to help people in terms of monitoring this carbon credit business, because there is going to be a broker agency which is going to certify these carbon credits, and then the emitters are and the sequesters, there has to be an intermediary person or a regulator, and assessment of these effects on grounds requires mega efforts. It's not possible by doing in situ conventional system. So large amount of remote sensing inputs are going to go in this type of businesses also. So carbon farming is another business scenario which are likely to grow as we talk about the climate adaptability, etc. So in last, I would simply say that we need to now start placing people at the heart of climate action. We need not worry, because many things are not in our control. Only control will come when we are running, or when we'll run out of hydrocarbon resources. I can tell you that whatever people may talk about, unless the hydrocarbon reserves are going to get depleted, humans will continue to emit the way we are emitting. But what we need is now to think, seriously teach and develop curriculum for climate adaptation using various technologies which are going to come in future. So with this, once again, I would like to thank each one of you for giving me this opportunity to share some of my views, and my greetings from Dehradun to each one of you. Have a wonderful time. Thanks a lot, sir.
Thank you, sir. Thank you, sir.
Thank you so much, sir.
Thank you very much, sir.
Thank you for
Thank you for such a wonderful and insightful lecture, and it was pleasure listening to you, and so many aspects of climate change and its consequences which you have highlighted in your lecture was worth listening, and not only listening but also following it. And as you have mentioned, capacity building is a key where we have to bring people to a platform where we all think at the same energy, or we develop the same synergy, that yes, this is something that we have to look forward to. And you have rightly said that we human beings will only come to our senses when there will be no fossil fuel left behind. So thank you, sir. And also,
I think, Abrina,
yes, sir. Yes, sir.
the most credible point Dr. Prakash ji has brought is very well connecting the remote sensing and the climate change, the different dimensions,
Very true.
and how remote sensing is going to be helpful in terms of mitigating the current climate change. Most important, the mitigation. And his last point is that climate action, that's the most important thing, that unless and until we have some climate action group, and the protocol of the climate action group again demands a lot of deliberation, a lot of researches. And unless until we do it, possibly the mitigation and to achieve the sustainable development goal may not be feasible. So thank you, sir.
Thank you.
Thank you very much.
And I also like to take this opportunity to mention here that we have Professor Siddiqui here with us in the panelist, who's been, very instrumental in helping me out, in many ways for this conference. And of course, I would take this opportunity to thank him from here. Thank you, sir.
Thank you, Amrina, for giving me space. Thank you.
Thank you.
It was a very nice opportunity to listen Professor Prakash Chauhan ji and my teacher, Professor Pradesh Nath ji. This was very good opportunity. Thank you.
Thank you, Professor Siddiqui.
Thank you. Ladies and gentlemen, it has been a very fruitful and insightful journey. Amity University, Uttar Pradesh and Indian Meteorological Society, New Delhi extend heartfelt gratitude to all our eminent speakers, guests of honor, and chief guests for making these 3 days so productive. As a token of love and affection and beholding the lifelong memories, we would like to share a glimpse of this journey. So, with your permission, I would like to share my screen. Thank you so much for watching.
Thank you, Dr. Marina. Thank you.
Oh, I have to stop share. Okay, so we have come to the end of our 3 days workshop. Now I request my colleague, Dr. Richa Davinagar, Assistant Professor, Amity University, Uttar Pradesh, to please propose the vote of thanks to the August gathering. Over to you, Richa.
Dr.
Thank
Marina.
you, Dr. Amrina.
Excuse me, Dr. Chair. Before vote of thanks, is possible we should take a group photograph.
Yes, ma'am.
So I request all to please turn on your camera for a group photograph. Okay. Thank you, Dr. Marina.
Thank you.
Thank you, Dr. Amrina. So after the group photograph, namaskar and very good evening to all respected dignitaries, distinguished participants, and my dear colleagues. Thanks for being with us for the successful completion of the 3 days workshop cum training program on climate modeling and remote sensing applications for environmental systems, jointly organized by Amity Institute of Environmental Sciences and Indian Meteorological Society. With the world facing new challenges every day, it is becoming highly imperative to address the issues of climate modeling and remote sensing applications for environmental systems, which has been emphatically addressed by the workshop cum training program. I'm sure all our participants have gained new insights into the topics covered. It is a privilege and a great honor for me to extend a formal vote of thanks to all present here on behalf of Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, and Indian Meteorological Society. At the outset, I, on behalf of the entire fraternity of Amity, would like to convey my deep regards and thanks to Honorable Founder President Sir Dr. Ashok Kumar Chauhan Sir for his continuous guidance and encouragement. We are grateful to President and Chancellor Sir Dr. Atul Chauhan Sir and our Honorable Vice Chancellor Ma'am Professor Barwinder Shukla. We are highly obliged to Professor D.K. Bandyopadhyay Sir, Chief Advisor FPO and Mentor AIS for his esteemed guidance to execute the program and his continuous blessings for all of us. We are thankful to Dr. D.R. Patnaik, Secretary IMS and Head NWP IMD, and Dr. V.K. Soni, Scientist F and Head EMRC IMD, for their continued support to organize the workshop in collaboration. All through the 3 days of the workshop, all our esteemed speakers have engaged our participants into a journey of learning and gaining through their vast experience. We are thankful for the special address by our guest of honor today, Dr. Prithvish Nag, Director, National Atlas and Thematic Mapping Organization, Kolkata, Surveyor General of India, Scientist, Engineer, ISRO, former Vice Chancellor, Mahatma Gandhi Kashi Vishwanath University. We thank him for deliberating on most important issues and how to address them with the coming scenario. We are thankful for the valedictory address by Chief Guest, Dr. Prakash Chauhan, Director, Indian Institute of Remote Sensing, IIRS, Dehradun, Uttarakhand, India. I'm sure all of us have gained a new insight into all problems that climate change and the coming scenarios are posing to humanity and the world, and how remote sensing can bring so many solutions to the fore. Further, I wish to express our profound gratitude and appreciation for thanks for gracing the occasion and highlighting the importance to all our dignitaries today. I would also express my thanks to the event organizers, Dr. Renu, Dr. Amrina, and Dr. Manju Rawatranjan. I humbly thank all the participants who have attended the workshop. Your interest and active participation are a great encouragement to all of us. I would be failing in my duty if I do not convey my gratitude to the administration of Amity University for the efforts they have made for the efficient conduction of this event. I must thank Dr. Renu, Dr. Manju, Dr. Amrina, the conveners, Dr. Manoj for all assessments of all the sessions, continued support from all faculty members, Dr. Ashutosh, Dr. Karthike, and our staff, Mr. Satish and Mr. Naresh and Mr. Jaidev, for unending support all through the workshop and for being involved in this particular exercise for last many days. We would like to thank the esteemed delegates, the scientific community, colleagues, and research scholars for being an integral part of this event. Finally, I would like to take this opportunity to place on record our hearty thanks to admin, IT team, AUUP for the perfect support. In the end, I once again thank the distinguished assemblage in the 3 days workshop cum training program on climate modeling and remote sensing applications for environmental systems. Thank you so much. I hope the workshop has brought new and engaging ideas for all to address. Thank you.
Thank you, Richa.
Thank you, Dr. Richa.
Thank you, Dr.
Thank you, Dr. Richa. Thank you for vote of thanks. Thank you, Prakash sir. Thank you, Prithvish Nag sir. Thank you so much for gracing and this occasion.
Thank you, sir. Thank you.
Thank you, sir. Thank you. Thank you so much.
All the best.
Thank you, sir.
Thank you so much, sir. Thank you, sir.
Joining us. Thank you.